Hi everyone, my name is Christina Prella.
And my name is Janet Carr. Welcome to another episode of the Women in 3D Printing podcast. In spirit of the upcoming TIPE 3D Printing virtual conference taking place January 27 to 28th next year, 2021, we are going to be dedicating the first series to the TIPE. So you might be wondering, what is the TIPE? TIPE represents the tracks for the conference: technology, industry, people, and economics.
And as your hosts, we are so excited to share our conversations with these trailblazing women. The all-female speaker lineup we have prepared for this conference is made up of women that have carved their careers in additive manufacturing and have inspired all of us. We can't wait to introduce them to you so you can get to know them before the conference.
So we invite you to hit that subscribe button, follow us on LinkedIn, and get to know the stories of these awe-inspiring women before the event.
We'd also like to give a shout out to our platinum sponsors, HP, Trumpf, Matter Hackers, GE Additive, and Dassault for making all of this even possible.
I'm really excited to announce the upcoming Women in 3D Printing TIPE speaker. She started her additive manufacturing career in academia and later on joined a startup called Morph3D and hopped on over to Boeing. Her name is Melissa Orme, Vice President of Boeing's additive manufacturing.
The reason why we're hosting this podcast is because we really want to get to know who you are. Before we jump in, Melissa, what launched your career in additive manufacturing? How did you get into all this?
This is a really interesting question, and my answer that I have to warn you is kind of long, all right? And it really goes back to when I was a PhD student studying aerospace engineering, actually several decades ago. That's why my answer's long. My thesis was experimental research focused on generating and manipulating the trajectories of nanoliter droplets composed of low vapor pressure oil. And so this original application was for a radiator that would radiate these, heat from these droplets flying in space, right? So it was that I did this experimental work in a 6-meter long vacuum tube, and that length was really necessary to measure the really small angular dispersions of how we steer these streams. I know it sounds like I'm veering off topic, but you'll bear with me, you'll understand how this fits. So my work went further to create new methods of manipulating the sizes of these droplets in a really controlled manner so that I could customize the sizes of the drops in this continuous stream. And this hadn't been done before, and it earned several patents. And so I could also customize the electrostatic charge of these droplets, allowing me to effectively steer them in space. Now, this was in the time period that happened to coincide with the original stereolithography work of Chuck Hull, in 3D systems, as well as the powder bed work being developed out of the University of Texas, Austin. And that work really excited me. I was a PhD student. I was always, looking at new technologies and trying to figure out what was happening, how we were moving forward. Because I developed methods of controlling streams of droplets to really high precision, I thought that my research would apply to what we were calling at the time net form manufacturing. We hadn't yet started calling it additive manufacturing. In fact, out of the University of Texas, Austin, they called that solid freeform fabrication, and I think they still have a conference now that's called the SFF conference, solid freeform fabrication. So because of that, I created now an experimental apparatus that would replicate my work on the oils, but do it for metals, molten metals. And so I began with solder, and then I moved to aluminum. And I found that I could create net form manufactured components with a really high degree of precision in a very fast way, faster than current powder bed. And so I went on to receive my PhD degree, and I went on to become a professor at the University of California, and I continued to develop this technology in academia. There I received a really good grant funding, a lot of recognition for net form manufacturing using controlled molten metal droplets. And so I was working towards developing this into a feasible technology because, in an academic environment, it's still very laboratory and so forth. So what happened next, for personal reasons, I relinquished my university tenure and joined my family, and we moved to Greece. And so that sounds very off the wall, but it's a decision that I made, and I'm, look back, I'm glad I did that, but it's very unusual, right? And so I walked away from this technology before I was finished developing it. I still think it holds great promise, and occasionally I receive some communications from others asking me if I'll revive it and so forth. But anyway, my family came back to Greece. We came back, and I was removed from academia for 6 years. So I didn't try to return to the university. But what I did is I engaged with a few other startups before I found Morph3D, which is a company that uses powder bed technology for flyaway hardware for the aerospace industry. One of their customers is Boeing. They have several other aerospace companies as well. I was appointed Chief Technology Officer at Morph3D, and I enjoyed that position for over 4 years, at which time I was asked to join Boeing, the Boeing team as Vice President. So at Morph3D, I kind of felt that I came full circle in a way, not knowing that I was yet to join Boeing, but that we were using AM technology, even though it was not the same as what I was so engrossed in when I was doing research, but it had a lot of the same similar characteristics, building with metal in a layer-wise fashion from CAD data and really working on improving the microstructure. So I came from, a laboratory environment, developing technologies and powder technologies to the environment where we were using it for industry. Now I'm Vice President of Boeing, really working to create, additive parts for our products, as well as, continuously looking and evaluating the new technologies. So that's a long answer.
Wow, that's fascinating. What did you do in Greece during this entire time?
Good question. Well, when I was in Greece, I was working with my husband in another startup company that he has, and it's still ongoing. And it has to do with, he has invented a CT scan that works off of ultrasound, not X-ray, and it's for early detection of breast cancer. And I was basically the Vice President of Clinical Research, and it sounds totally orthogonal, but it's very related to the research because the way I was creating these droplets was with, ultrasound essentially. And so there were a lot of piezo, we used piezoelectric transducers. I mean, it was a lot of the same technology, but embedded in the apparatus in a different way and looking at the signals in a different way. For a completely different application. And so we went to Greece to further that technology, to do validation trials. My husband's Greek, so we went there. And we also used the opportunity to bring our kids, to learn a new language, to have them spend time with their grandmother. So there was so many reasons, but I was not involved in additive manufacturing at all during that time.
Obviously, you'll never get tired of aerospace, but you can always come to the medical field because
your
talent would be wonderful there.
I'd love this. And even with additive, right? There are so many great applications for medical. And I mean, that's one place that it really fits, right? Because human beings are one of a kind. They're one-offs, right? And like for bone replacements and things like that, you can get a CT scan and have the exact geometry for that individual, so that there's no, say you're doing a hip replacement, you get the exact geometry, so there's no compensation of that patient's gait, to something that's kind of a foreign dimension, So I think that there's a really good play also in medical, which they're exploiting right now.
Yeah, that's fascinating. They got the medical device side, the bioprinting, and personalized medicine. It's fascinating what can be done. Speaking of which, with all these changes, going from academia to startup to the aerospace sector, what are challenges that you have faced or are trying to overcome during these times or throughout your career?
Basically, I look at it two ways. So I can look at it from a personal point of view and challenges that I have faced, and then challenges that AM is facing and that we're looking to overcome, right? That's a little easier one for me to answer, actually. But, personal challenges, I kind of think I'm not like the typical person, in either academia, because I relinquished that career, which people don't do that because it's a guaranteed salary until you die, basically, right? And I did that, and I left, my family, my mother, my sister, my brothers, and my friends, and moved to Greece, where I didn't speak the language. Put my kids in a Greek-speaking school, had to converse with their teachers in my broken Greek. I learned it. Right? So I'm somebody who, always pushing myself, out of my comfort zone, doing things a little differently. I think that we need to take really smart risks. I'm glad that I left academia. I rose to full professor, which was really the highest, with tenure. And then I figured I had talents. I should be able to figure something out with my life, right? And I wasn't sure what that was, but it brought me here. All those things. So for me, it's always about taking smart risks. Don't be complacent in your position. Working hard to figure out what your next step is. Continuously working on things that motivate you. I think that I could have stayed in academia. We wouldn't have gone to Greece. I would still be a very senior professor there. That would be an interesting life. But I think that I've done so many other things instead because I pushed myself out of my comfort zone to do difficult things. For me, that's really rewarding. So challenges that I'm facing, in many ways, I think I face the same challenges that every woman in manufacturing faces, right? When I was a student studying for my undergrad in aerospace engineering, there was a class of 80 people and there were 3 women. And then when I went to get my PhD, I'm not really sure how many there were, but I was the only woman. And then when I became a professor, a young assistant professor, I was the only woman all the way to when I left. So I've always been a singularity. And sometimes that's hard and sometimes it's not, right? I mean, clearly people know who I am, right? I'm the singularity and maybe that has worked to my advantage. So it's not all negative, but there are challenges in having people, take you seriously. Women in positions like mine feel that we have to work twice as hard, to be recognized, because if we fail, it will be because we're a woman. That's what people might think, right? So we don't want to fail. So that caused me all my life, I think, to work very hard, kind of to prove myself, where my male counterparts probably didn't have to do that, but I don't regret it because I think it served me well, right? I worked really hard. I got scholarships. I was promoted. I got good positions, all because I worked really hard. So you have to look at both sides of the equation, right? So in terms of challenges, I would just say I don't know if I would actually call that a challenge, but it's something that has caused me to reflect how I view life, how I work, what my goals are, and how I expect to achieve them.
Thanks, Melissa, for sharing that. That's super inspiring.
Yeah.
Reminding us that we're not alone and there are pros and cons of being a singularity in this industry. The good thing is, it seems like there's been an increase of more women representation all over the industry, which is fascinating.
Yeah, it's really wonderful, especially, looking at the, women in 3D printing. There's so many women just in 3D printing, right? Not even the larger field of manufacturing or even larger of engineering. I mean, there's really has attracted a lot of women, and that's really inspiring.
Yeah, I think there's, to date, Women in 3D Printing has over 10,000 members in 60 cities,
Wow.
25 countries. So yeah, that's
wonderful. Really, really wonderful. Yeah.
I don't know if you're allowed to touch on challenges in the aerospace industry, but would love to hear about that.
Yeah. Oh, that's right. I was going to complete the question with challenges in the aerospace industry. So there are a lot of things you can imagine that I'm not going to touch, but I can talk about laser powder bed technology in general. In reality, I'll let you know, I'm waiting for those machines to be industrialized. For example, we may have 2 exact models of the same machine, same brand, same model, but they provide data with different mechanical values, different surface roughness, for example, with the exact same build file and the exact same parameter. This is because the machines, even though they are, the same make and model, they're fundamentally different machines. They're made like, they seem to be made like they're prototypes. And you can tell this just if by opening the cabinet doors of the machine, and you can see that the wiring's not even the same between the two. So there's not a standard process in which they're making these machines, and that makes a difference to how they operate. And so that sort of machine behavior may be okay for, consumer products, possibly automotive, but it's not okay for aerospace, and it's not okay, I'm sure, for medical, like we were discussing before. For the FAA, we need to show repeatable, reliable data across machines. And so what happens is that, companies, get their machines and then they have to open them up and they have to start tweaking and modifying them so that they behave similarly. And so I think that's a really big challenge for additive in general. And secondly, I think that we need to think out of the box with respect to technology. People talk about scale, and they immediately talk about, okay, adding more machines. Let's just get like a football stadium and just line them up, or they will say, well, let's just add more lasers. I really think that we need to think out of the box. There's a limit to how much we can do by adding lasers and adding actual machines. I'm waiting for the next leap in technology, and we really don't even know what that is. So don't get me wrong, powder bed technology is good and it's useful, and we're making really good parts with it. It provides really good benefit of understanding AM, and I think it's a necessary step in our technology path. But I'm not sure, in 10 years if we'll still be focused on powder bed, and I'm not sure what it is that we'll be focused on, to be quite honest with you. I'm excited to see something that's something completely new, but basically it needs to provide bigger, faster, and repeatable, reliable printing. That's what the next technology needs to address.
I look forward to the day when every machine, make and model are exactly the same.
Yeah.
Just like we do with our printed parts.
And I think they can. It's just basically, we're still kind of an immature technology, and I think they're getting better. But in the beginning it was still sort of experimental, and we continue to improve, and it can be that way, right? If we make it in a factory such that there is a standard process on how they're made.
We're about 15 to 20 years into metal production, so hopefully over the next 5 to 10 years, hopefully sooner, we can solve this problem.
Yeah, exactly. Yeah.
That said, as your experience at Morph3D for introducing, additive into the aerospace industry, and also now being on the OEM side at Boeing, are there any kind of stories or tips you can share about how do you bring a business case for additive successful? And what are typical pitfalls some folks might fall into?
Oh, the pitfalls are easy to address, really easy to address. I saw those all the time. And that's when people would say, I want you to print me this cup, or I want you to print me this flat plate with 8 holes in it, this flange. And you'd say, why? And they'd say, because I want it to be 3D printed. And the biggest mistake is thinking that you could and should 3D print anything. And so, first of all, that won't make a good business case, because it's going to be a lot more expensive. Your flange with a O-ring groove and 8 holes in it. It's going to be actually hard to make, because it's going to be big, and depending on what it's made of, it might warp, it'll just be, big, thick, flat plates aren't the best things to make for additive, right? So it's going to be expensive, and it won't make sense. So that's a huge pitfall right there. In terms of making the business case, I would say I would rather point to my Boeing experience than Morph3D experience there. And really say, or in general, to any group that's looking to make a good business case, it's difficult to make a good business case with a part-for-part replacement on an existing platform. And the reason being is that if you have a heritage part on, say, some vehicle, right? It could be airplane, could be, a motorcycle, could be anything, right? So you have a heritage part, and you redesigned it for additive, but it has to go exactly where it went. and it has to mate with the existing pieces that are also not changed, well, you're not able then to modify it enough. You're not able to optimize it because it has to fit in the same bolt pattern, right? It has to fit with the existing parts around it. So you can't optimize it for volume and weight, the way you can if you just started with a brand new idea, a new whole vehicle essentially, or you were allowed to redesign a large part of that vehicle, right? So part for part replacements, unless it's combating obsolescence, or you need a quick spare, it often won't make a business case, a strong business case. Where additive, in my view, really makes the business case, and where we find that value is if we use it to create differentiating vehicles, not parts, vehicles, or I should say products. So I like to look at it as optimizing the product, not optimizing the part, right? So in the case of aerospace, where can we make that airplane have a more streamlined body, a thinner fuselage, thinner wings, or likewise for other vehicles and a satellite, where can we take out the mass so that we could put in more payload, right? Things like that, where we get a lot more value if we look at it from a vehicle point of view rather than a part point of view.
I hope that inspires folks as to how they want to build their business cases when introducing additive there.
Yeah.
That said, it kind of touches on what we just talked about, but are there any other experiences or failures that you've turned into successes over your career?
I'd rather talk like Boeing, for example, we have uncovered many issues, just like everybody who uses these additive manufacturing machines has uncovered issues, right? In our machine operations, in our post-processing operations, that lead to part failure. So I'm not at the liberty to discuss exactly what those machine issues are, or what those post-processing issues are, or how we solved it. And I think most people are in the same boat as me. But that said, what we do is we look at those issues and we find the smartest people in our group or in our company, and we come up with really innovative solutions to solve those problems, right? Of course, these are innovative solutions that we don't share outside the company. So I think that we're all sort of repeating this, which is a lot of repetitive work that kind of behind closed doors. But I can answer your example, your question with other examples from industry, towards specific examples of part building. For example, problems with the industry, additive is so new that we can't rely on the heritage, decades of data that subtractive does, right? We don't have that statistical MMPDS data for each alloy, and complicating things, making it even worse. If you have a certain chemistry of your alloy, well, it doesn't have a fixed material properties, right? Because that depends on how you fabricate it. It depends on your laser parameters, right? It'll have different porosity, different strength, different fatigue values, depending on how you choose to have the laser interact with it. And this adds a whole new level of complication about curating tables of data, based on material chemistry. But we really need data, statistical data, especially for, regulators such as the FAA and other regulators. So the one thing that I'm seeing to combat this issue is that the industry and the regulatory bodies are addressing this. And they're creating consortia to develop material databases based on parameters, so that the industry can get over this hurdle. It's a little early to call it a success, and it probably would have been extreme to call it a failure in answering your question, but I think it's a really good response to a problem in the industry. Other technological advances that turn failures into successes are the development of in-situ monitoring, right? Where we can reduce failed builds and due to lack of fusion or melt pool anomalies, or automated support removal to reduce failures, due to sort of the brute force operations and the lack of repeatability because it is a manual operation. Automated depowdering, I think we've all seen some really good advances there, and that really helps with the repeatable, reliable post-processing. Repeatable, reliable doesn't just correspond to the machine operation, but to every single step in the value chain. And, if you have a very complicated part with, very narrow channels that are, in a serpentine path, if you just, wiggle it, it's hard, and you need to have that programmed and done the exact same way each time. And also software, as you're aware of, right? There's a lot of really good software solutions now that will predict part warpage for certain orientations and parameters, and this allows you to optimize how you're going to create this build to minimize part failures, right? So I think there's still a lot of work to be done on that, but it shows a lot of promise, and there's still, there are good results to be obtained from existing software, that allows us to mitigate those failures. So basically I see that there are a lot of technological advancements addressing what the industry in general sees as failures, I guess, from existing technology.
A point you made very well, whether it's within your own company or within industry as a whole, it seems like the common factor is collaboration is really key to bring all the bright minds together to see what are different ways we can solve it. Can we create a consortium, start looking at the data, start connecting that digital thread to figure out what might be the issue. You also mentioned a lot of amazing future developments, but what are you most excited to see about additive manufacturing development in the future?
Well, I'm really excited to see things that will surprise me, first of all, because I always like to keep an open mind and not assume that I know what the next things will be. So, brand new technologies, and what really they need to address size constraints. They need to be faster, and they need to pay attention to the details of repeatable and reliable production. So there's technologies that are exciting, like neutron beam technologies that have the benefits of electron beam, but also the improved surface finish. I'm eager to see some of the large area extrusion capabilities, see how they mature, as well as blown powder, to see how that matures. And as I said before, I'm really looking forward to being surprised because there's a lot of really smart minds out there creating, brand new technologies, and we really need to keep an open mind and not be complacent, with existing technology with what we have now, and allow for that new innovation to come and help us.
So for all the people that are in the audience that are starting new technologies or cooking something amazing, maybe at their university lab, how do they get in front of an organization like Boeing to pitch such an idea? And if you guys are interested in testing it out, what is the best approach to exploring if there's an interesting fit?
That's a very good question. How do you get in front of a big organization like Boeing? The really neat thing about Boeing is that we have this group called Boeing Horizon X, and that's an investment group that invests in startups, basically, and you can pitch to that, and they're basically they'll look at all of the small companies, and they'll say, does this add value to Boeing if it were to be developed further and transitioned in something that could be commercialized, right? So that's one way, would be to get it out in front of Horizon X. Also, before that, if you want to stay in a university and it's not in the startup field, there's plenty of ways. Boeing works with universities really all across the country and outside, with the Cambridge and Queensland. There's just internationally as well. So we have a lot of collaborative projects with universities, and so the PI of that project really just needs to find who the right person is, to talk to, and there are ways to do that, so it would be, if anybody would want to know, they could ask me, and I could try to deflect them, to redirect them, I should say, to the appropriate person. But we do a lot of collaborations with universities, and that's really, really useful. That's where a lot of, I'm partial to universities. I like, I spent my career in academia as an experimentalist, trying to push boundaries and explore new things. And that's where all of the innovation starts. Powder bed fusion started at University of Texas, Austin, as we discussed. So, we like working with universities. Yeah.
I think of all people, you're probably the best person to ask what are 3 tips for getting someone into additive manufacturing, because you have the academic background, you have the startup background, the service bureau background, contract manufacturer as well. I guess I would put morph into that, and also OEM at Boeing. What are some tips that you can share so that folks could follow your lead and become vice president of additive manufacturing one day?
Well, I mean, first of all, I first you have to have a very open mind, right? Not assume that, the way things are, the way things have to be, right? So, I mean, for getting into AM, and if you're looking at it from a designer point of view, forget everything you learned about traditional manufacturing, right? So think about, forget about what parts look like right now and focus on what a part needs to do. It'll probably end up looking really different from your preconceived notion, right? So if you're designing for additive, you also need to do it in a holistic sense. That is, in the design phase, think about everything that part will experience. And that means, if it's going to be machined, have you put machine tabs on it where it can be held? Is there a proper datum? It's really hard to go back and change your engineering. Can you hold it in a test fixture? Is there a surface on it that you might want to put a strain gauge or an accelerometer on it? You have to think about all those things in the design phase, because it's really hard to do it after engineering is locked. If it needs to be CT scanned, to make sure that every aspect, can be inspected, things like that. And also avoid, when you're thinking about additive, avoid part swaps, as we talked about before. This particular part would be really nice additively manufactured, but think about, the spaces on the platform you're designing for, and how can you make them all better? How can you make them smaller, thinner, streamlined? Think about creating a differentiating product, not a differentiating part. That's what I really like to say. I think the real value is looking beyond the part level and looking at the vehicle added value level. And finally, on a personal note, like, read as much as you can. Become aware of the limitations of the different AM technologies, and they all have different limitations. And know when and where to use each one. Be smart about it. Don't think additive is like a fix-all and that each technology is the same. They're not. They all have advantages and they do all have limitations. So understand them, read a lot, know what the technologies are, follow your passion, work hard, aim high, and go for it. Those are my tips.
You said read more. Are there like top books or articles you recommend?
I think very useful is to read literature, read from the peer-reviewed journal articles, read from conference proceedings. A lot of these you can find online. Really, the Solid Freeform Fabrication Conference that's held in Texas almost every year except for now, in August, has a lot of really good content. So this is scholarly work that allows you to understand what's going on. And then you can read more high-level things. Join all the AM groups in LinkedIn, right? And you're going to see what everyone's posting, and you get an idea of what the barriers are, what the hurdles are, what people are experiencing. There are a lot of groups, in LinkedIn that you can join. And your feed will be 100% dominated by AM, and read those articles. And that some of them, point you to nice magazines, that give a more comprehensive detail on technology or its usage, and, case studies, things like that. So yeah, just become aware of what's out there. You can do it in a scholarly level, and you could just do it in sort of, more of a magazine level.
That ends very well, because we will have the Type 3D Printing Conference where everyone can learn a little bit more about what 3D printing has to offer under the technology, economic, people, and industry arm. Thank you so much, Melissa, for your time.
I enjoyed this very much. Thank you for inviting me. It was my pleasure. And I look forward to the conference. That's going to be a lot of fun.
Thanks again for joining us at the Women in 3D Printing Podcast Type Series. If you like our content, please hit that subscribe button, follow us on LinkedIn or other social media platforms.
We'd also like to give a shout out to our platinum sponsors, HP, Trump, GE Additive, Matter Hackers, and Dassault for making all of this even possible. So mark your calendars for January 27th to 28th next year in 2021.
And visit us at type3dprinting.com to save your seat. And feel free to drop us a line if you have any questions or feedback.